In this video, we'll be applying Newton's method to approximate the root of this function near 1. Now, if you were to type this equation into the calculator, again, you can identify very clearly what the root is, but that's not the intent of this practice. This practice is to get us the concept of how we're approximating the root. Now, recall, the root is going to be approximated using Newton's method such that x is equal to x1 minus the original function at 1 divided by the derivative function at 1. Okay, so what we're going to do is we're going to go ahead and start off by finding the derivative of this function. So f prime of x is equal to 5x to the fourth minus 3x squared plus 4x. Now, what I can do is I can go ahead and plug this formula into here, plug this formula into here, and be able to identify what x2 is. So x2 is going to be equal to x1 is the value of 1. Again, that's the one we're going to utilize to start this approximation because that's what we're close to. So I'm going to go ahead and plug in 1 for x1 minus, I need f of 1 divided by f prime of 1. Again, that's the formula for x sub 2. This is going to provide me with 1 minus, and again, I'm just simply plugging in the values. So 1 to the 5th minus 1 to the 3rd plus 2 times 1 to the 2nd minus 1, all divided by plugging in 1 to the derivative function in the bottom. So that's 5, 1 to the 4th, minus 3, 1 squared, and plus 4 times 1. Now this one here you could probably do in your head quite quickly and then approximate to the best of your ability. What you'll come to the conclusion to is that x2 is approximately equal to, using a calculator to get this rounded off, 0.83333, and basically it's 3 repeating. So I'm going to write 1, 2, 3, 4, 5, 6, 7 3s because that's about how much your calculator will be able to do. Now this is your x2 value. This gives us a value that we can approximate our actual root with. So I got 1 to start. That was the one I used to start. Now I've gotten back this value. To find my x3, again, hopefully my x3 will be closer to that of my actual root value. I'm going to use x2 in place of all these x1s in this formula. So I'm going to have 0.83 repeating minus, again, I'm going to go ahead and that's my x1, so now it's my x2, minus f of, again, 0.83 repeating divided by f prime of 0.83 repeating. Now again, I would strongly suggest that in a calculator you actually type all this information in and get this to the best of your ability. Utilize the ask function with your table setting to be able to do this relatively easily. You can go ahead and type in y equals, and then you're going to have your x value minus the function divided by the derivative function. Then your x value is nothing more than these values you have to plug in for your table. Now if you do this and do it correctly, your approximation for x3 is going to be 0.7754171. So now notice it's changed from 0.83 to 0.77, and we're a little bit closer to what we would assume my actual root is. Now we shouldn't stop doing this, so I'd do x to the fourth, and again I'd plug that 0.7754171. I'm typing all that in this time because again the 0.3 repeating, I can't abbreviate this using that tool. So I'm going to have f of, again, 0.7754171, and I'm going to divide that by, again, the derivative at 0.7754171. When I plug all this information in again into a calculator very carefully, f is me plugging it into this function up here, and f prime is me plugging it into this function right here. Then I'm going to divide those two, and again I'm going to subtract it from this decimal value here, which will provide me with a 0.77005822. So you'll notice here that 0.83 was first, after we again assumed 1 was a root. Then we got to 0.775. Now we're at 0.7700. Now I would argue, based on this information, we're getting closer and closer to the root being somewhere around 0.77 and again, assortment of other values. We're going to continue to plug this in again until, if I want to approximate this root, to say 3 decimal places, then I can't be certain that I've got this exact approximation until those 3 decimal places occur at least 2 to 3 times in a row on my approximation. So in x5, when I go ahead and plug in that 0.77205822 minus, again, f of that number divided by f prime of that number, and I get back approximately for the next value a 0.77001784, I would argue that we're getting closer to assuming that 0.770 is my best approximation of where my root is going to be. But you'll notice if you do this one more time, again, I'm going to go ahead and just assume that we know what's plugging in here. Again, it's this number plugged into this spot minus f of this number divided by f prime of this number. We get approximately 0.77001784. And you can be absolutely certain that that is the best approximation because it has occurred twice that that is my actual root showing up for the where the tangent line approximation is going to identify that value. This is all Newton's method is. It is a bunch of formulas that look like that to approximate the x value that we're looking for.